Hi guys, welcome to 4.3, solve systems of equations using elimination. So the equations in the setup is going to look very familiar. In fact, here's an example I want you guys to do on your own, and I want you to use substitution, all right? Push play when you're ready to go over it. So to use substitution, as you know, you need to solve for either an x or a y, whichever one looks easiest, and I'm going to go ahead and solve for this x. So by doing so, I'm going to subtract a y. Okay, and that'll give me x equals negative y plus 7. And what I'm going to do is plug this x value into this x here. So now I'm going to substitute. So 2 times negative y plus 7 minus y is 2. So that'll give me a negative 2y plus 14 minus y equals 2. I'm going to combine my like terms, so negative 3y. I'm also going to subtract 14 along the way. Okay, so that'll give me a negative 12. Divide by negative 3, y is a positive 4. Now to find x, you plug it back into always an original equation. I know we have x over here, but to prevent mistakes and errors, you do always go back to an original. So I'm going to solve for x in this original equation. So x plus, instead of y, I'm going to use 4. Equals 7, so minus 4, x is 3. So my solution to this system of equations would be 3, 4. Okay, so now what I'm going to do is we're going to take this exact same problem where we got the answers 3, 4, which I'm going to write up in the corner, and we're going to use a different method. We're going to use a method called elimination. So elimination tends to be people's most favorite when it's set up for it. When it's set up for substitution, we'll go for substitution, but elimination tends to be our go-to. So I'm putting a little star next to it. Put a little heart. Okay, so what we're going to do for elimination, what you want to do is make sure everything's stacked up. So your x's are stacked, your y's are stacked, your equal sign is stacked, and your 7 is stacked. So you're just, or not your 7, sorry, your number, your constant is stacked. So everything's stacked up, so we're ready to eliminate. And what I want to do is we're going to eliminate an x or a y. So what I'm scanning is for the leading coefficient here. I've got a 2 and a 1. Those aren't going to eliminate very easily. So let me look at my coefficients in front of the y's. I've got a positive 1 and a negative 1. Ooh, this is set up very nicely for elimination. So what I'm going to do is simply add the two equations together. 2x plus 1x is a 3x. Negative y and positive y cancel each other out. They eliminate. 7 plus 2 is 9. Divide by 3, x is a 3. Ooh, isn't that what we got over here? Check. And then now to find the y value, you just plug into the original equation, any one. I'm going to pick this original equation. So 3 plus y equals 7. Minus 3, y is a 4. Check. Ooh, so elimination can sometimes be a quicker route to go. So we're going to just practice elimination for a few examples, and then we'll look at some where you get to choose which method you prefer. All right, so solving this system of equation, the first thing, guys, you want to make sure everything is stacked up or lined up. So your x's are stacked, your y's are stacked, your constants are stacked, and your equal sign is stacked. Everything needs to be stacked. Then the second thing I'm going to scan is which do I want to eliminate, my x's or my y's? We'll look at the y's. They have the exact same coefficient, so you want same coefficient. If they don't have the same coefficient, we're going to make it the same coefficient in a little bit. So they have the same coefficient and opposite signs. This one's negative, this one's positive. My y's are ready to be eliminated, just like the above example. You can eliminate x's too, it's just my y's are ready to go. So again, I'm going to add equations. 2x and a negative 1x is 1x. My y's cancel, equals, holy moly, that came out nice. X is 5, I'll take it. Now to find y, plug into an original equation. It doesn't matter which. I'm going to go ahead and pick the upper one. So I'm going to say 2 times 5 minus 4y is a 2. So 10 minus 4y is 2 minus 10. Negative 4y is negative 8. Divide by negative 4, y is 2. So my coordinate pair, my solution would be 5, 2. That would be the solution to my system of equations. Now, guys, you can check it by plugging in your x and y value into the other equation and make sure it works. So I'm going to change my color to a green. I'm going to check it. So what I'm going to do is it's a negative 5 plus 4 times 2. Does that equal 3? Negative 5 plus 8. Is that going to equal 3? Yes. So that means I'm right. Feels good. All right. Now let's look at the next example. We're going to solve by elimination. So first things first, make sure everything's stacked. Okay, your x's, your y's, and your constants. Hooray, everything's stacked. Then you want to decide which variable you want to eliminate. So you're looking for the same coefficient. Remember, coefficient is number in front of a variable. So coefficient, I've got a 2 and a 1, and then I've got a 3 and a 2. None of them are the same. What we're going to have to do here is make them the same, okay? In a fraction, you would call it a least common denominator. Here, we're just going to get a same coefficient. So what would be easier to make them look the same? Well, 3 and 2 can become a 6, or 1 and 2 can both become a 2. So I'm going to eliminate my x's here. And by doing so, I'm going to make them both become a 2, except I'm going to make the top equation be a negative 2. So I'm multiplying by negative 2 to then make, so if I distributed my negative 2 in, I'm going to get negative 2x minus 6y equals negative 14. And I'm just going to write the second equation, just rewrite it, 2x plus 2y equals 6. So what I did is I multiplied the top equation to specifically get it set up and ready for elimination. I'm going to go ahead and change my color because now I made same coefficients, just opposite signs, and they're going to deliberately cancel each other out. So negative 6 and 2 is a negative 4y, and then let me see, negative 14 plus 6 is a negative 8. Divide by negative 4, y is a 2. Now, guys, here's where I'm going to give you some advice. Please be clean and organized. I see people try to do this in your head or let work get really messy. With elimination or any systems of equations, having organization and taking a moment to write the equation again is really valuable and prevents so many mistakes. I cannot stress that enough. Now, let's finish the problem. Let's go ahead and find y. So I'm going to pick this original equation to find y. So x plus 3 times 2 equals 7. So I simply substituted in y. So x plus 6 is 7 minus 6. X is 1. So my coordinate pair, my solution to the system of equations is 1, 2. Okay. So if you feel ready, why don't you try this one on your own and then push play to check your work. Okay, guys, so let's go ahead and solve using elimination. Make sure you're stacked, x's above x's, y's above y's, equal sign above equal, and constants above constants. If it's not stacked, make it stacked, sort of how you would manipulate it to be substitution. You can always manipulate equations. Okay, so now let's look at, do we want to eliminate our x's or our y's? Okay, here's our x's, here's our y's. If they were both the same coefficient, that would be nice, but they're not. So I could either make my x's both become a 6, or I can make my y's both become a 6. Well, the x is going to be easier because you already have 1 6, so I simply just need to multiply the bottom equation by a 3 to make that also a 6, but keeping it negative. So I'm going to multiply this whole equation by 3. So this would give me negative 6x plus 9y equals, don't forget, negative 15. As you can imagine, many people forget to multiply that one. And then I'm simply just going to write the top equation up top, not changing it, okay? It's so much value in rewriting it and taking time to be clean and organized. So check this out, guys. Your x's eliminate as planned. And then I'm going to have 7y equals negative 14. Divide by 7. Y is a negative 2. Okay, let's find x. Which equation do I want to use? I don't know. I'll pick the upper one. So I'll say 6x. They both look the same. That's why I didn't spend too much time deciding. Negative 2 times negative 2 equals 1. 6x plus 4 is 1, minus 4. 6x is negative 3, divide by 6. X is negative 1/2. Okay? Now, if you're like me and you're like, ooh, a fraction, could it be? Well, let's check it. I'm going to check it using the bottom equation, okay? So this is my check. What I'm going to do is plug in x and y and make sure it works. So negative 2 times negative 1/2 plus 3 times negative 2 equals negative 5. Let's see if this works. So negative 2 times negative 1/2 is a 1. Minus 6 is negative 5. Indeed it is. So our solution here is negative 1/2, comma, negative 2. So yes, guys, fractions and decimals also are answers to your systems. We obviously prefer fractions. All right. Now I want you to try this one on your own. Okay, so welcome back. Let's see. Make sure you're stacked. We are indeed stacked. And decide you want to eliminate your x's or your y's. If I eliminated my x's, I'd have to make them a 6. One a negative 6, one a positive 6. If I eliminated my y's, I would make them a 10. Ooh, well, one's already 10, so that's less work. So I'm going to eliminate my y's. And remember, guys, you want opposites. Since they both have the same signs here, I am going to multiply by a negative to purposely make it an opposite. So I'm going to multiply by a negative 2. Okay, so then this would give me negative 4x minus 10y equals, don't forget that guy, your constant, negative 6. And then we're just going to rewrite the bottom equation next to it. Okay, now since I've multiplied, now I'm ready to go for elimination. Add your equations. So negative x equals negative 9 divided by negative 1. X is 9. All right, so now let's go ahead and find our y value. I'm going to pick the upper equation. They both look pretty easy, but the upper equation is smaller numbers, which is just what I'm preferring right now. So 2 times 9 plus 5y equals 3. So 18 plus 5y is 3 minus 18. 5y is negative 15. Divide by 5, y is a negative 3. Okay, guys, and I hope you've noticed by now, once I find my x and my y, I do group them and make a coordinate pair out of it, because your solution is a coordinate pair. So do group them together back as a coordinate pair. Okay, so here's a good one. Choose a method of solving. Well, if you look at this, this is so ready for substitution. It is perfect for substitution. But what I want to do is show you how to get it set up for elimination. You can use any method you want, like if it says use any method, but for this case, I want us to use elimination. So on purpose, oops, sorry, I'm not sure why that's happening. So on purpose, I want to manipulate this and get it ready for elimination for us, okay? So elimination, everything has to be stacked. So it's not, I need to bring my y to the other side. So this would be x plus y equals 6, and I'm going to simply write the above equation above it. 3x minus 2y is 38. Okay, now I'm going to eliminate. What do I want to eliminate, my x's or my y's? Well, I can make these both become 3's or these both become 2's. I'm going to go for the y's because I've already got opposite signs, which is already a little nicer for me. I just need to multiply the bottom equation by a 2. So that would give me 2x plus 2y equals 12. I'm going to simply just write the upper equation above it. And now I'm ready to eliminate. 3x and 2x is a 5x. Goodbye to your y's. 40, that's a 50. Divide by 5, x is 10. Okay, and now to solve for y, let's go ahead and plug it in. Any equation's fine. 10 equals 6 minus y. Minus 6. 4 equals negative y. And then divide by negative 1. Negative 4 is a y. So your solution here would be 10 comma negative 4. Now, if you're sitting here and you're like, elimination would have been, substitution would have been so much easier. Sure, you could substitute, and substitute would be another way to check it. So in fact, I'm going to use substitution and check it, okay? Now, the easiest way to check is simply by just plugging it in, but because I'm teaching, I want to prove to you that substitution will also work. So 3 times 6 minus y minus 2y is 38. 18 minus 3y minus 2y is 38. Let's minus 18 here. And let's go ahead and combine your 3 and 2y, so that would be a negative 5y equals 20. Divide by negative 5. Oh, hello, y is negative 4. That's what we got. And if you plugged y back in, you'll get 10 is x. So I used 2 different methods to check my work here. So I checked by substitution. Okay, so here I have just 4 different equations, and what I want you to do is spend some time looking at them and just decide which method you would use to solve. So let's say I gave you an option. Which method would you use to solve? Would you use, don't forget, we have the graphing option, we have substitution, and then we have elimination. So pause this and go ahead and decide which method you would choose on each. Okay, so welcome back. So let me start with this. Any method would work, okay? Any method would work and get you the correct answer as long as you did your work properly. However, some methods are easier than others given how it's set up. Graphing is usually the least preferred, okay? It's also can create error because it's hard if your solution is fractions or anything like that. Graphing isn't very exact or precise. So really, it's in between substitution or elimination unless you had a graphing tool. So in number 1, I see that a variable is isolated. So for me, it's like, okay, that's substitution. That's ready to go. I'm going to use substitution there. For number 2, I see everything's lined up, everything's stacked. That's an elimination. That would be the easiest approach here. Number 3, everything is stacked up nicely. So again, my approach would be an elimination. And then number 4, x is already solved for. That's a variable. So that would be a substitution. Substitution. And number 4 is the previous slide. We already did that one. All right, guys. So here's just a little slide of substitution versus elimination. Substitution is typically when you've got a variable already solved for, okay? Or it's easy to solve for a variable. That's usually a good route to use substitution. Elimination is good when you've got everything stacked up. Then you just get a common coefficient and you go along your way to eliminate. So thank you for tuning in. I wish you the best of luck and have a great day.